Hey everyone, hope you all are doing well. Welcome back in our series, The Reasoning List. In previous episodes, we learned how to count the total number of triangles or squares from the given figures by using some handy tricks. So today, we are going to learn how to count the total number of rectangles from given figures in similar fashion. If you haven't watched the previous two episodes of this series, then the link is in the I button. Check them out as well, you're gonna love them too. So without further ado, let's start with the episode 3. Let's start the video with a very basic figure. Count the total number of rectangles possible in this figure. Pause the video right now to give it a try by yourself. You have 5 seconds. Done? Let's see how it's calculated. So one way is just to manually calculate the total number of possible rectangles in this figure. So as we can clearly count, there are minimum 5 possible rectangles in this figure. 4 small ones and 1 the biggest one. Also, if we observe more carefully, there are 2 horizontal rectangles forming by combining first, second and third and fourth rectangle. Again, if we combine first and third and second and fourth rectangle, there are 2 more vertical rectangles forming in this figure. So in total, we have 9 possible rectangles in this figure. But in order to calculate more faster, we have one simple trick in order to calculate total number of rectangles in such figures. And the trick goes like this. First, mark total number of columns present in the figure. In this figure, let's start from the left top rectangle. So there are 1 and 2 columns present in this figure. Similarly, we mark total number of rows in this figure. And we can see there are 2 rows in this figure. Now, here comes the short trick. Add up all the numbers in the first row and write the sum on the right hand side. Like in first row, we have 1 plus 2 equal to 3. Similarly, we do it for the first column. Add all the numbers present in the first column and write their sum below, which we get as 3. Now, multiply both the sums we got and we get the total number of possible rectangles in such figures. That is 3 into 3 equal to 9, which is same as our manually counted answer. Let's take a look at one more example to get this more clear. Now, how will you calculate total number of rectangles in this figure? If you would like to, pause the video and give it a try by yourself. For the rest, let's see how it's solved. We are only going to solve this figure using a short trick, because if we try to go for the manual method, there is no guarantee that we would get the correct number of rectangles in this figure. Also, it would be very lengthy. So referring to our short trick, we first mark total number of columns and rows in this figure. So in this figure, we have 3 columns and 3 rows. Then we add up the numbers in first row and we get total 6. Similarly, we add up the numbers in the first column and we get the sum 6. Then to find the total number of possible rectangles in this figure, we multiply both the sums and we get a final answer. That is 6 into 6, we get 36 possible rectangles. Isn't it too easy? This is the most simplest trick for finding total number of rectangles in such figures. Now, if we see from the exam point of view, we know we won't be encountering such simple figures. So now let's see somewhat different figures that might be asked from the exam point of view. Let's look at those. Now, try to find total number of possible rectangles in this figure. Pause the video to give it a try. When you're ready, continue with the video. Okay, counting total number of rectangles in this figure is very easy and very similar to the last one. Again, we follow a same short trick. First, mark the total columns and total number of rows. Step 2, add all the numbers in the first row. Here we get 6. And add all the numbers in the first column. And here we get 10. Finally, to get total number of possible rectangles in this figure, multiply both the sums we got and here we get 10 into 6 equal to 60 possible rectangles. This was of the type where number of rows and columns are not equal. Now, before jumping to more complicated ones, let's see some basic concepts in order to tackle those difficult ones. Now let's calculate how many rectangles can this figure possibly have. This is a very basic figure, so we can just manually count total number of rectangles in this figure. Like there are 3 visible rectangles plus 1 the biggest rectangle, so 4, plus first and second rectangle combined forms 1 rectangle, and second and third rectangle combined forms another rectangle. So in this figure there are in total 6 rectangles possible. But what if you encounter a figure like this one? If you try to count it manually, it will consume more of your precious time during the exams, and you might find it difficult to count and keep in mind which all rectangles you have already counted and which you haven't. So the very basic trick to solve this is just numbering the clearly visible rectangles and just summing them up in order to get total number of rectangles, just like our previous figures. So in this figure, number the rectangles that you can clearly see. So here we have 8 rectangles. Also note that we are going to add these numbers in order to get our total number of rectangles. But instead of adding these numbers from 1 to 8, we can simply use our natural numbers summation formula in order to calculate total number of rectangles possible in this figure, because this is similar to the addition of natural numbers. So here we can use the formula n into n plus 1 by 2, and thus we get total number of possible rectangles in this figure equal to 8 into 9 whole divided by 2, which is equal to 36. Thus there are 36 possible rectangles in this figure. Now let's quickly try to calculate total number of possible rectangles in this open figure. Do you want to give it a try? Pause the video if you want to. As you have tried, continue with the video. Even though the figure is a little different as it's an open figure, but the trick to solve this is same as the previous ones. First of all, mark all the visible rectangles in all rows and columns possible. So first we can see there are 4 rectangles in first row. Similarly, the column has 4 rectangles and the second row also has 4 possible rectangles. Now sum up the numbers and write their sums in front of them. So the first row adds up to 10, the column adds up to 10, and the second row also adds up to 10. As we did previously, to find total number of possible rectangles, we add these sums. And in this case, we would get 10 plus 10 plus 10 equal to 30. But unfortunately, this is a wrong answer. Do you know the reason why? Well, if your answer was the first and the last rectangle in the column are acting as a joint between rows and columns, that is, the first and the fourth rectangle are joining both the rows to this column, then yes, your answer is right. So remember, whenever you see such small rectangles that are acting as joint rectangles that are joining rows to columns, make sure you subtract them from our total summation we got. In this case, there are 2 joint rectangles in this figure, so we need to subtract 2 from our total summation we got. Thus, the actual number of total rectangles possible in this figure will be equal to 30 minus 2, that is 28. Let's see one more of this type to get things more clear. Try to find total number of rectangles in this figure now. Again, relying on our basic trick, first number the visible rectangles in rows and columns. In first row we have 4 rectangles, in column we have 4, and in second row we have again 4 rectangles. Next, we sum up the numbers and write the summations in front of them. So the first row summation is equal to 10, the column summation is also 10, and the second row also sums up to 10. So the total summation we get is equal to 30. But again, in this figure there are 2 rectangles acting as joining rectangles or joint rectangles, and we know we need to subtract those rectangles from a total summation in order to get total number of possible rectangles. So thus the actual possible rectangles is equal to 30 minus 2, that is equal to 28. And this is it everybody, this is it for today. But before concluding today's video, let's go to a summarizing table of this video. So these are the 4 types of problems that we encountered today, And the only trick most commonly used in these types of figures is using our summation technique. So whether it be type 1, type 2, type 3 or type 4, the main approach towards these questions is just number the rectangles from first row and first column, calculate the total sum, add up those numbers separately, get the individual sums, and multiply the sums of column and row and get the total number of possible rectangles. Only in the type 3 and 4 there is a little bit different approach. Like in type 3 there are not multiple rows involved in this figure, so the total number of possible rectangles in this case is just summing up the visible rectangles in the first row. And in type 4 you just have to add 1 or 2 steps more than the type 3 example. Feel free to take screenshot of this table as it would come handy in revising the tricks and you don't have to go through the entire video. So thank you all once again for sticking with me till the end of this video. Make sure you hit that like button if you have gotten more clarity on this concept. Don't forget to drop your feedback in the comment section below about the content on this channel. Also, I would like to request you to hit that subscribe button and the bell icon beside it in order to get notified about the future content in this channel. Also, it would boost my confidence even more in order to upload such content with more speed. So this is it everybody. Thank you so much for watching the entire video. I'll meet you in episode 4 of the reasoning list. Until then, keep learning, keep upskilling. See ya.